section 8.6, we're going to look at using factoring to make predictions with quadratic models. In example 1, we have the defense funding for research and development in the United States declined in the early 1990s but has increased since 1997. So we have some data here from the years 1989 through 2001, and we've been given a model for that data. Okay, so this is our model in T years since 1989. That model has been graphed with the data already for us. If it wasn't graphed, I could make a scattergram of the data and graph the model. And the first question is, does the model fit the data well? Okay, it does fit it well. It's not perfect. I might be able to get a better model that would go a little bit lower to include this point. So it fits it okay. So it's not the best fit, but the model does fit the data. It's not way off. All right, part B. Use the model to estimate when U.S. defense spending for research and development was $43 billion. So the model, 1/9 t squared minus 2t plus 48 equals 43. I want to get this equal to 0 so I can factor. So let's subtract the 43 off. That'll give us 1/9 t squared minus 2t plus 5, 48 minus 43 is 5, equals 0. Now I'm going to want to factor this to solve, so let's make sure to multiply everything by 9 to get rid of that fraction. It's a lot easier to factor if you don't have a fractional coefficient for the first term. So this is going to be 9 times 1/9 is 1t squared minus 18t plus 5 times 9 is 45 equals 0. Let's factor this. 45 to 45, I need two negatives to multiply to a positive 45 and add to a negative 18. So 45 is negative 5 times 9. That's going to add to negative 14, so it's not going to work. 45 is 3 times 15, so negative 3 and negative 15 add to a negative 18, so that pair will work. So this is going to factor into t minus 3 and t minus 15 equals 0. So if I solve each of these equations, t minus 3 equals 0 and t minus 15 equals 0. That'll give me t equals 3 and t equals 15. Let's verify these from the graph. 43 corresponds with the two values t equals 3 and t equals 15. So we can verify that from the graph here. So there are two different years where the defense funding is going to be $43 billion. We're talking in years since 1989. So it's going to be in 1992 and again in 2004. So because the budget is going down and coming back up, there will be two different years, 1992 and 2004, where the budget is going to be $43 billion. What is the vertex of that model? Okay, so we can see from the graph that the vertex of the model is 9, 39. Let's verify that by using negative b over 2a. So x equals negative b, so negative 2 over 2a. A is 1/9. Okay, so I have 1, if you cancel your 2's, over 1/9, and 1 over 1/9 is 9. That's my x value. To find the y value, I could take 9 and plug it into the equation. So if you take 1/9 times 9 squared minus 2 times 9 plus 48, you can verify that you get 39. What does this mean? The x value 9 corresponds to the year 1998, and in 1998, the defense spending was $39 billion. In general, when you're asked to find the vertex, you're going to want to use x equals negative b over 2a, this method here, because it may not exactly fall on an integer value. We can verify that what we find looks like it does match the graph, but in most cases you will not have exact numbers right here, so you're going to want to calculate those. In Part D, we want to estimate the U.S. defense funding for research and development in 2005, and then the actual amount was $66 billion, so we want to calculate the error in the estimate. Alright, so 2005 corresponds with the t value 16. So if I plug 16 in for t, we're going to have 1/2 times 16 squared minus 2 times 16 plus 48. If you simplify that, you're going to get 44. So that's 44 billion. And the actual amount was 66, so what's the error in the estimate? The error in the estimate is 66 minus 44. The error is 22 billion. So since the error is so large in the future, in 2005, it's just saying that this model is probably not going to be a very good indicator anymore once you're past the data set. So it's going down, it seems to be going back up, but it's not going to follow this quadratic trend and go back up as far as it was before. Okay? It's always good to know what the limit to your model is. Let's look at the second question. Example 2. A company's profit can be modeled by P equals t squared minus 8t plus 20, where P is the profit, and t is years since 2005. First, we want to predict when the profit was or will be 8 million. So I'm going to plug 8 in for P. 8 equals t squared minus 8t plus 20. And we want to solve this, so we're going to subtract 8 from both sides. We're going to get 0 equals t squared minus 8t plus 12. And then if we factor this, we're going to be able to solve. So when I factor this, I need two numbers that multiply to 12, both negative, to get that negative 8 there. So we're going to use, let's see, negative 6, negative 2 to get negative 8. This will factor as t minus 6 and t minus 2. So one option is that t minus 6 equals 0, so t equals 6, or t minus 2 equals 0, so t equals 2. Okay, so since I was starting at years since 2005, t equals 6 corresponds to 2011, and t equals 2 corresponds to 2007. So in both of those years, 2011, 2007, the profit was 8 million. In example 3, a batter hits a baseball into the air. The height h in feet of the baseball after t seconds is given by the formula h equals negative 16t squared plus 80t plus 4. The first part asks, when is the baseball at a height of 68 feet? So 68 is the height. We're going to plug that in for h, and we're going to need to solve for t. So we're going to have to get this equal to 0 again. So our first step is going to be to subtract 68 from both sides. Anytime I have a quadratic equation that I need to solve, it needs to be equal to 0, so I can factor it. So if 0 equals negative 16t squared minus plus 80t, and then minus 64. Notice that all three of these terms can be divided by something. It looks like 16 goes into all of them, so we're going to divide out a negative 16 since the coefficient of the first term is negative. So let's factor out negative 16. That's going to leave us with t squared. Positive 80 divided by negative 16 is negative 5, and negative 64 divided by negative 16 is positive 4. So I'm going to put my t there. Okay. So now I want to factor the trinomial that we have left here. It has coefficient 1, and I have to work with 4. Again, that's positive, and I need two negatives to add to negative 5. So we're going to have to use negative 1 and negative 4 to get that negative 5. So this will factor into 0 equals negative 16 times t minus 1 times t minus 4. Now there are three parts to this product, but 16 has no variable term, so that part can't equal 0. We're looking at t minus 1 equals 0 or t minus 4 equals 0. So it gives us the two solutions, t equals 1 and t equals 4. So the baseball is at the height 68 feet twice when t is 1 second and when t is 4 seconds. Explain why there are two such times. Well, the baseball is going to go up, hit 68 feet, keep going, come back down, hit 68 feet before it comes down and hits the ground. So that's why there can be two different times where it hits 68 feet. When does the baseball reach a height of 104 feet? Okay, so we're going to solve the equation again. This time it's going to be equal to 104. So I have 104 equals negative 16t squared plus 80t plus 4. If we subtract the 104 off from both sides, we're going to have 0 equals negative 16t squared plus 80t minus 100. Now once again, there's something that you can factor out of all of these, and this time it's 4. Since the first term is negative, we're going to divide out a negative 4. So that'll be negative 4 times 4 t squared minus 20t plus 25. Okay, now let's factor again. I'm going to factor by trial and error. 4t can be written as 2t times 2t. And one of the ways to multiply to 25 is with 5 and 5. Now I know that my last term is positive and I have a negative middle term, so I need two negatives. Let's see if we got it on the first try or if we need to try again. It's 4t squared minus 10t minus 10t, which will add to negative 20t, so it's perfect. Okay, let's continue solving. We know that negative 4 cannot equal 0 since there's no variable, so we're looking at 2t minus 5 equals 0, or 2t minus 5 equals 0. It's going to give us the same solution. So I have 2t equals 5, or if you divide by 2, t equals 5 halves, or 2.5. So after 2.5 seconds, the ball is at 104 feet. Explain why there is only one such time. Okay, I know the ball is forming a parabolic shape since the equation is a parabola. At any point, it's going to hit that height twice until it hits the vertex. So that must be the vertex right there. When is the ball at a height of 110 feet? As we've just said, the vertex is at 104 feet. So 110 feet is somewhere above the vertex. We know that the ball will never hit 110 feet. Let's look at the next one. Example 4. A rectangular hallway's floor has an area of 64 square feet. If the length is 12 more than the width, let's find the dimensions of the floor. So a rectangular hallway has an area. This is rectangular, so area is length times width, and length times width is 64. If the length is 12 feet more than the width, so we have our width, and our length is 12 feet more than the width, find the dimensions. Okay, so length is 12 plus w times width is w equals 64. It's going to be the equation here. Let's distribute. We have 12w plus w squared equals 64. This is a quadratic equation, so we can solve it by factoring. I want to write the w squared first. So I have w squared plus 12w, and we'll subtract the 64 over to get it equal to 0. Now let's factor. Negative 64. I want one positive and one negative to add to negative 12. So if I try negative 8 and positive 8, I'll get 0. If I try 32 and 2, I'll get 30. Okay, those don't work. If I try 16 and 4, I'll get 12. So that one does work. This is going to factor into w plus 16 and w minus 4. W plus 16 equals 0 gives us the solution w equals negative 16. And w minus 4 equals 0 gives the solution w equals 4. the width cannot be negative. Length and width must be positive values, so therefore the width must be 4 feet. Now, if the width is 4 feet, remember that the length was 12 plus w. So therefore, the length is 12 plus 4, or 16 feet. So the dimensions are 4 feet by 16 feet.